Hello everyone, let's solve the second problem from LeetCode Weekly 334. Find the divisibility array of a string. You are given a zero index string word of length n consisting of digits and a positive integer m. The divisibility array div of word is an integer array of length n such that divisibility div of I is equals to 1 if numeric value of word of 0 to that index I is divisible by m or 0 otherwise. Return the divisibility array of word. Let's see an example. 9982444353. M is 3. 9 is divisible by 3, so 1. 99 is divisible by 3, so 1. 998 is not divisible by 3, so 0. Similarly, 9982 not divisible. 99824 not divisible. Finally, at this index, the substring form would be divisible, so 1. So like that. So what would be the approach for this solution? So here is our example. So if we can think in a naive way, what we can think of, let's say we keep a number, say num, and then at each step we will form this number. First we will form 9, then we will have our divisibility array, right? 9 is divisible by 3, yes, so put 1. Then add 99. 99 is divisible, yes, so put 1. 998, is it divisible? No, so put 0. Then add 2. Is it divisible? No, so put 0. So like that we can do it. Now we are given that n can be as big as 10 power 5. That means our length of the string can be 10 raised to the power 5. So if we try to form this num, our value will overflow. Even if we take long, it will overflow, because for long it is at max 10 power 18, which means at max 19 digits. But we have been given that n can be as big as 10 power 5. That means 10 power 5 digits, right? So there is no way we can fit that, adjust that in a long or int, right? So we have to think in some other way. What are we going to do? Let's say this is our number, okay? A equals to b into m plus remainder. Okay, now in order for this to be divisible by m, our remainder has to be 0, right? If that is the case, then we will add a 1 to our array, right? Now suppose we add a new digit in our array. What would happen? How will we add it? We will do a multiply by 10 plus the new digit, say d, right? Which is b into m into 10 plus remainder into 10 as well, plus d, right? Now in order for this new number to be divisible by m, if this has to be divisible by m, this remainder part has to be 0 again, right? Let's call it, say a dash, b into 10, say b dash into m, plus now let's call this r dash. Now when we add one more digit, it would become like this: a into 10 plus d, b m into 10 plus r dash into 10 plus d, right? So for this, again, for this new number to be divisible by m, this remainder part has to be 0, right? Say we have this number, say 9. 9 is divisible by 9, right? Now when we add 9 to it again, it will again be divisible by 9. Then let's say we will add 5. It is not divisible by 9, right? This would be the remainder. Now let's say we add 4. This becomes another 9. Then it would become divisible by 9, isn't it? So when we added this new number to our remainder, 5 was our remainder, and it became divisible by 9. What does that mean? That this thing is also divisible by 9, right? So at each step we are checking if our remainder is divisible by that number or not, because if the number was already divisible by the number and the new remainder that we have achieved is also divisible by our number, then the whole number will become divisible, right? Say x is divisible by, say m, and then we have a remainder. Okay, when will this whole thing give us a 0? When this is also divisible and then this is also divisible, the remainder is also divisible. What does that mean? This means that the whole number is divisible, right? So we are trying to see if our remainder is divisible by our m or not at each step. So say if this is our number, we will add our new digit, right? If this is divisible by m, that means this is divisible as well as this remainder is divisible, right? What will happen? This modulus m becomes a 0, as well as this modulus m becomes a 0, right? This becomes a 0. Then in it we will add our new digit, that means 0 into 10 plus c, right? Now if this is again divisible by what? If this is again divisible by m, that means it will again give me a 0, right? Now what is 0? 0 is the remainder, right? After dividing a number, if we are getting 0, that means 0 is the remainder, and on it we are multiplying and adding this, right? That means we are doing our operation in the remainder only, and we will do that only. Okay, that is, for each index we will see if our remainder is 0 or not. If it is 0, that means it is divisible, otherwise it is not. Okay, now let's try to code it. So we will have our, say, div only, right? And we will have a remainder variable. Why long? See, because m can be at max 10 power 9, right? So in order for our remainder to be divisible by m, our remainder has to be in this order, greater than this, right? Then only it will be divisible, right? Say this is our remainder, and if we take it an integer, that is at max it can be 10 power 9, but as soon as we multiply a 10 with it, that's what we are going to do, right? This will become 10 power 10, that is it will exceed the integer limit. That's why we have to take a long, right? So long remainder. Now for, let's iterate in the string, I equals to 0, I less than word dot length I plus plus, what is the number? Remainder into 10 plus that digit at that index, that is I minus 0. This is a character, this is also a character. We are subtracting the ASCII values to get the actual digit, right? Then we will perform the modulus. If this remainder is 0, that means the number is divisible, the number from starting to that index is divisible, right? So at that case we'll put a 1 in the answer array, otherwise we will leave as it is. At the end, return div. Let's try to run it. Okay, accepted. So this is our solution. What will be the time complexity? Pretty easy. O of n be the length of the word, and our space complexity is also big O of n. We are using this extra space if you want to consider it. So this is pretty much our solution. If you like the video, hit the like button, share this video, and subscribe to my channel if you haven't already, and I will see you in the next video. Bye bye.